Welcome to the professional case study for our data center project. This session is the kickoff meeting, and it marks the beginning of a structured record of the work ahead. Today's material is presented as the minutes of the meeting held on August 1st, 2022, under Nexra Engineering and Construction. Nexra is identified here as the main contractor, with responsibility across the CSA and MEP scopes. That combination is important because it brings the core construction disciplines and the building services disciplines together within one coordinated project framework. This is also the first entry in a 100-plus week minutes of meeting learning series. So this page is more than a cover. It establishes the project context, the ownership, the meeting format, and the longer-term documentation approach. As we move through the case study, the meeting record will provide a consistent way to follow the project's development over time. For now, the key point is simple. This is the formal starting point for the data center project and its ongoing learning series. This slide establishes the meeting record and document control framework for the data center project. It identifies the document as the kickoff meeting minutes and baseline control record, with meeting ID DCP KLM 001 for week 00, dated Monday, August 1st, 2022. The main contractor is Nexra Engineering and Construction, covering both CSA and MEP responsibilities. The purpose is broader than simply capturing discussion. This record sets the project scope, baseline controls, delivery interfaces, governance, organization, mobilization, and early work readiness. It also creates a clear record of decisions, constraints, accountable owners, and target dates for the first weekly control cycle. The intended distribution includes the steering committee and the key delivery functions, from project leadership, commercial, and planning through CSA, MEP, HSE, QA/QC, BM, and testing and commissioning. The central principle is one record, one accountable action trail, and one weekly control rhythm. In practice, that means every important decision should lead to a visible owner and a controlled follow-up. The abbreviations shown on the slide provide a common reference for everyone using this meeting record. This slide provides the roadmap for the data center project kickoff and training case study. It shows how the material is organized, so we can move from meeting fundamentals into governance, delivery planning, and project control. The first section covers meeting control, the KPI dashboard, and the definitions we'll use, across pages 2 through 7. We then move into the governance and integrated control system, which forms the framework for coordinating the work, on pages 8 through 19. The third section focuses on scope, the program, and the 2-week look ahead, pages 20 through 24. From there, we turn to organization, staffing, and site readiness, including the practical conditions needed to support execution. The final 2 sections address progress evidence and its interpretation, followed by decisions, actions, and continuity. Together, these 6 sections take us from how the project is controlled, to how progress is understood, decisions are made, and the work stays aligned over time. This structure is designed to support a consistent approach for the main contractor across both CSA and MEP activities. This slide summarizes the project's initial setup and the controls agreed at kickoff. The immediate priority is to establish the baseline program for a 13-month works completion period, while preparing the project quality plan, project HSE plan, and major method statements. Communication and acceptance protocols also need to be defined, and IFC, or issued for construction. Drawings must be released quickly so the main contractor can develop shop drawings. The scope is to complete the full phase 1 day 1 works. Procurement is moving forward, with the tower crane appointed and orders progressing for ready-mix concrete, reinforcement bar, and bore piling. Temporary power, water, security, and site office arrangements are also being developed. Staffing currently includes 26 people, with 15 mobilized to site and additional candidates expected within 6 weeks. On site, surveys are complete, office containers and basic facilities are operating, and temporary utilities are being prepared. Utility control is critical before piling begins, particularly for existing dam water, PLN electricity, and gas services. This dashboard establishes the project's starting position at kickoff, using a red, amber, and green control view across the main delivery areas. The overall valuation is red, meaning this is a conditional start, not a fully released production phase. The program baseline is 13 months, while site mobilization is only 15 of 26 staff. Dam protection is green, with 214.90 square meters wrapped by July 31st. However, utility clearance remains red because PLN and gas are still open, creating a dependency for piling. Cost and valuation are not evidenced, and the budget and certified value have not yet been issued. Engineering is also red, with IFC foundation information still required. HSE readiness, quality readiness, procurement, and MEP commissioning are amber. In practical terms, the plans and governance exist, but approvals, field evidence, IDP holdpoint releases, and early procurement gates still need to be closed. Commissioning begins at CXL 0 through design review. The management interpretation is clear. Enabling works may proceed under control, but production piling must wait for formal evidence across baseline, IFC, utilities, HSE, quality, and commercial valuation. This slide establishes the KPI control matrix that will govern reporting from week 1 through week 110. Each domain is assessed through 5 lenses: the current value, the acceptance gate, the RAG status, and an owner-focused interpretation that explains what action is required. Program, cost, HSE, quality, mobilization, procurement, MEP, and commissioning and data assurance are all amber. In practical terms, these areas are still being established and require approved baselines, plans, registers, or evidence before performance can be fully valued. The engineering and utilities workfronts are red. IFC information is needed immediately, while PLN and gas utilities remain open, meaning piling cannot proceed until the affected area is demonstrably safe. The continuity rule is equally important. If a value is not supported by evidence, it remains marked N/E or not evidenced, rather than being treated as complete. This creates a consistent reporting spine, linking every weekly KPI to an owner, target, value, variance, RAG status, and narrative. The objective is not simply to collect numbers, but to control release, readiness, and accountability across the project. This project charter establishes how success will be defined before mobilization begins. It is a training case baseline, so these targets still require formal client approval before they can be used contractually. The central principle is that success must be measurable, owned, and controlled. The first dimension is business and capacity. Deliver the approved phased data center capacity while protecting future expansion, maintainability, and live site interfaces. Scope and technical success depend on freezing the owner's project requirements, design basis, redundancy intent, room data sheets, and phase boundaries before procurement. Time is controlled through the stated 13-month works completion baseline, approved milestones, clear critical path ownership, and quantified recovery actions. Cost and change management require one approved budget and commitment baseline, with every movement in scope, time, or cost supported by a traceable decision. Safety, quality, and environmental performance rely on permits, inspections, hold points, evidence-based corrective actions, and verification before work is concealed. Finally, operational readiness begins during design, covering completion, testing and commissioning, integrated proving, training, O&M information, asset data, spares, and warranties. Each success dimension has an accountable owner, making the charter a practical control framework rather than a statement of intent. This slide presents an integrated control architecture built around one source of truth. The central principle is simple. Every weekly statement must trace to a baseline, a register, an owner, and dated acceptance evidence. The control cycle moves from evidence to classification, decision, assignment, verification, and finally closure with lessons learned. That cycle is supported by core registers for actions, decisions, risks and opportunities, issues, changes, interfaces, and lessons learned. The table shows how this discipline applies across the project. Scope is controlled through the WBS and Responsibility Dictionary. Schedule management connects milestones, logic, critical path, forecasts, and recovery to regular updates and look-aheads. Cost and change controls capture budgets, commitments, forecasts, notices, and approvals. Design relies on the CDE and a master information delivery register. HSE and quality require permits, inspections, tests, observations, and NCR closure, supported by an evidence index. The same structure continues through procurement, long lead expediting, completion, testing and commissioning, and handover. In practice, each domain produces a recurring, auditable output, making accountability visible from kickoff through closeout. This slide establishes the architecture for tracking every project record from its origin through verified closure. The central control rule is simple. Every meeting statement, variance, decision, and closure must carry a stable record ID. That ID connects the baseline, accountable owner, due date, approval, and supporting evidence. The process moves in a clear sequence from baseline to variance to record ID, decision, action, evidence, and finally verified close. A record is not considered closed just because an action was discussed. The same ID must link the meeting statement to the responsible owner, accepted proof, approval, and any downstream update. The register then defines what information is mandatory for each record family. Actions require an origin, owner, due date, priority, and evidence. Decisions capture the question, options, authority, effective date, and affected records. Risks, issues, constraints, and opportunities track cause, impact, response, and residual exposure. Changes include scope, time, cost, notice, quotation, and authority. Finally, technical records, inspections, nonconformances, commissioning, systems, and tags connect accepted information to workfronts, closed punches, and the next release gate. This slide defines the governance and meeting operating model for the data center project. The key principle is that every forum has a clear purpose, an accountable chair, and a controlled output, so meetings lead to decisions and traceable actions rather than discussion alone. The weekly MOM is the central control point. It covers progress, forecasts, registers, decisions, actions, and gate releases, and results in an approved record with updated registers. Daily coordination focuses on workfronts, permits, access, safety, logistics, and immediate constraints. Design and BAM manage requirements, interfaces, clashes, and information release, while procurement and commercial control long lead items, notices, changes, and forecasts. HSE and QA/QC track inspections, NCRs hold points and corrective actions. MEP and TNC focus on system completion, energization, testing prerequisites, interfaces, and turnover readiness. At the top level, the steering committee, chaired by the project director, resolves red issues, approves baseline changes, and provides strategic direction. The proposed MOM rule is straightforward. Draft within 1 working day, allow 2 working days for comments, and treat silence after that window as no further comment, subject to the contract procedure. This slide defines the weekly MOM data cycle, from the agreed cutoff through validation, meeting decisions, and controlled issue. The central principle is evidence currency. Information is current only when it is valid at the agreed cutoff and linked to its ID. Superseded, rejected, unapproved, or unlinked evidence cannot support a green status. The process begins with field updates, where discipline leads refresh quantities, dates, inspections, deliveries, constraints, and forecasts. At T-2, document control freezes the reporting set and records exceptions. At T-1, controls, QA/QC, and MEP reconcile the schedule, registers, approvals, commercial position, and commissioning gates. During the weekly MOM, the project manager accepts the position, decides red items and releases, and assigns accountable due dates. After the meeting, document control issues 1 numbered draft on T+1 working day. Attendees and the PM can submit evidence-backed corrections by T+2, with the change trail retained. Open items then carry into the next cutoff, where overdue actions, decisions, evidence, and approvals are aged and escalated. This creates a clear link between data, evidence, decisions, and accountability. This slide defines how responsibility is assigned across the data center project, from design basis through handover and change control. The matrix covers the client and project director, design, the main contractor's project manager, CSA, MEP and testing, controls, and operations or commissioning. The key principle is that every interface has one accountable owner. That owner is supported by a required by date, an acceptance criterion, and linked evidence, so responsibility is clear and completion can be verified. The RACI codes distinguish who performs the work, who owns the outcome, who must be consulted, and who simply needs to be informed. Some activities combine roles, such as design coordination, where design is accountable and responsible, or handover acceptance, where operations and commissioning witness or remain responsible. The rows follow the project lifecycle: requirements, design and permits, procurement, workfront release, inspections, system completion, integrated proving, and finally change, time, and cost control. Used consistently, this matrix reduces gaps between disciplines, prevents duplicated ownership, and gives the team a practical governance tool for resolving interface issues quickly. This slide sets out the information, design, and BM control chain for the data center project, from the initial requirement through to the approved as-built record. The sequence is deliberate: requirement, design or model, IFC release, shop drawing, method statement and IDP, construction and inspection, then redline and as-built documentation. No construction release is valid without the current approved information state, accountable acceptance, and a traceable transmittal. The controlled registers provide the governance needed to manage that sequence. The Master Deliverable or MIDP register tracks ownership, review, revision, and status, while the RFI register highlights unanswered questions that could stop or rework a workfront. The submittal register identifies what must be approved before procurement or execution. BM and clash registers confirm that spatial and access interfaces are resolved before fabrication. Field change records connect instructions and approvals to the as-built model, and transmittals prove who received the current revision. The weekly control questions turn these registers into active management, not passive filing. The prototype assumption is that response periods, information states, and model maturity remain aligned with the contract and the approved CDE procedure. This slide establishes the governance model for managing risk, issues, changes, opportunities, and decisions on the data center project. The key principle is to use the right record type for the situation, rather than treating every concern as a generic action. A risk describes a future uncertain event and should capture its cause, impact, probability, response, owner, and trigger. An issue or constraint already exists and is blocking planned work, so it needs an impact assessment, a required decision, an owner, and a due date. An opportunity records a beneficial option, including its expected benefit, investment, and decision window. A change tracks movement in scope, time, cost, design, or the contract baseline, with approval and implementation status. Finally, a decision makes the authorized direction explicit, including the options considered, the approver, and the effective date. The RACI logic provides the escalation signal. Red means immediate safety, legal, critical path, operational readiness, or authority attention is required. Amber needs mitigation or a due date commitment, while green means the response is effective and the remaining exposure is accepted. This slide defines the quality, HSE, and construction readiness gates that control release across the data center project. The central principle is no release without evidence. Every gate has mandatory proof, a named authority, and a clear consequence when requirements are incomplete. G0 covers design release, including approved IFC information, coordinated interfaces, and constructability review. Until that is complete, procurement or field release remains on hold. G1 verifies the method and materials with approved method statements, ITPs, competencies, permits, and temporary works design. G2 confirms the workfront is ready, including surveys, utilities, access, lifting, logistics, environmental, and emergency controls. G3 governs execution and inspection through pre-start briefings, WR and MIR records, testing, calibration, traceability, and NCR containment. Any issue means stop, correct, reinspect, and record. Finally, G4 confirms turnover readiness through punch status, test records, red lines, O&M information, asset tags, preservation, and the handover dossier. Across all stages, unsafe conditions, unapproved information, or failed acceptance criteria trigger stop or hold authority. No energization, functional testing, or acceptance proceeds until the evidence is complete. This slide defines the stage gate model for procurement and long lead equipment on the data center project. The purpose is not to create artificial certainty. Dates beyond the current look-ahead remain provisional until the required evidence is available. The gates move from design freeze to technical approval, commercial award, vendor data and factory acceptance testing, logistics and delivery, and finally installation and turnover. For every package, the weekly register should show the required on-site date, latest purchase order date, approval owner, current gate, forecast, recovery action, and a link to supporting evidence. The table organizes that discipline by package family. Civil and structural work must expose workfront, quality, temporary works, and storage risks. Electrical power, generators, cooling, and fire life safety systems require attention to design inputs, vendor data, testing, interfaces, approvals, and commissioning readiness. Controls, ICT, and security add point lists, protocols, cyber access, test scripts, and asset data, with particular focus on late integration and operational handover. Together, these fields make risks visible early and provide a consistent basis for governance decisions. This slide defines the commissioning control framework for the data center project, from design review through operational handover. The key principle is that MEP delivery teams execute the work, while the commissioning authority independently verifies evidence, witnesses required tests, and confirms acceptance at each gate. No level advances until the preceding evidence is accepted and the tag status log is updated. CXL 0 covers design intent, controls, redundancy, test strategy, and training needs. CXL 1 verifies factory performance and closes factory issues. CXL 2A confirms delivery and installation, while CXL 2B completes static and pre-energization testing. The tags move from red, meaning installed but not ready, to yellow, meaning static testing is accepted and energization may proceed. CXL 3 covers startup and pre-functional testing. CXL 4 proves functional performance, including capacity, sequences, alarms, and failure response. CXL 5 tests integrated systems and recovery under service-like conditions. Finally, CXL 6 transfers approved documents, asset data, training, spares, and known risks to operations. Conditional yellow is a controlled temporary exception, not a normal commissioning level. This slide establishes the MEP system register and TMS hierarchy for systems 01 through 08. The key idea is that each weekly MEP page becomes one governed system record, with a defined boundary, accountable owner, tag tree, interfaces, acceptance criteria, and evidence route. No system can claim progress until those controls are approved at CXL 0. The register covers the major data center systems. Systems 01 through 03 address cooling, fuel, and electrical power, including generation, UPS, and critical distribution. Systems 04 and 05 cover fire alarm and firefighting, with cause and effect, suppression, and life safety interfaces. Systems 06 and 07 cover clean water, drainage, rainwater, and treatment. System 08 covers ICT, from carrier entry through backbone, racks, and ports. Each row connects ownership to a TMS or commissioning hierarchy, then to weekly evidence and the next gate. That evidence may include design records, FAT, installation checks, functional testing, load tests, authority approvals, or asset data. In practice, this creates one controlled path from system definition to handover and prevents incomplete or unsupported progress from moving forward. This register defines the control and turnover structure for systems 09 through 15, plus integrated systems testing and operational handover. The key idea is traceability. Each system has a defined boundary, accountable owners, a TMS or commissioning hierarchy, and a weekly evidence path toward the next gate. No system may claim progress until those elements are approved at CXL 0. Systems 09 and 10 cover BMS and EPMS controls, alarms, trending, and plant optimization. Systems 11 through 15 address water leak detection, elevators, Yodi cranes, BMU or monorail systems, and security. Each row identifies what must be demonstrated, from points lists and sequences to safety certifications, proof load testing, coverage, access control, and failover. The integration row then brings these systems together through scenario testing, training, O&M documentation, and asset and TMS sign-off. The abbreviated hierarchies, such as service to network to controller to point, show how evidence is linked from the system level down to individual devices and tags. This structure makes ownership, acceptance, and readiness visible across the project. This slide defines the scope of works for Phase 1 Day 1 and shows how that scope extends into future phases of the data center program. The table covers 10 construction activity areas, beginning with early enabling works, site infrastructure, ground structures, the core and shell, architectural works, and facade protection. These are all included in Phase 1 Day 1, along with external and security works. The main distinction appears in the MEP infrastructure, data hall fit-out, and long lead equipment packages. For MEP, Day 1 covers the first 4 floors, levels 2 through 5 of the 9 building, while the next 4 floors are identified as future work. Data hall fit-out begins with the first 2 floors and the initial 2 megawatt IT load, with the remaining 6 floors planned later. Long lead equipment is also phased, with specific AD, mechanical transformer, RMU, generator, PTU, and load bank sets assigned to each stage. Testing and commissioning spans both phases, making it the key activity that connects initial delivery with future expansion. This slide presents the baseline program for Phase 1, Day 1, covering the data center project scope and program under Nexera Engineering and Construction as the main CSA and MEP contractor. The visible control window runs from July 2022 through September 2023, and the schedule shows both key milestones and longer work packages. The early milestones include the contract effective date on July 27th, site handover on July 29th, and receipt of the foundation IFC drawings on July 28th. Superstructure IFC drawings are shown as a 21-day activity from July 16th to August 10th, 2022. The overall Phase 1, Day 1 contract duration is 397 days, ending August 27, 2023. Major program streams include preliminaries, enabling works, tower crane activities, engineering, civil and structural works, architecture, MEP procurement and construction, and testing and commissioning. The timeline also separates foundation, 9 area, and gantry area activities. It is important to note that architecture and full MEP completion extend beyond the visible window, based on the baseline dates shown here. This slide establishes the measurement rules for maintaining baseline integrity and avoiding double counting across the data center project. The central control is that planned, earned, installed, inspected, and accepted are separate states, all reported against one approved data date. No activity receives credit simply because progress appears likely or partially complete. The process begins with the current approved logic-linked baseline, including the WBS dictionary, calendars, milestones, and common data date. Project and system weights must total 100%, and they remain locked unless an authorized change is approved. Credit for design, procurement, installation, and testing is earned only at predefined evidence gates, not through subjective percentages. Quantities also need to be reconciled by status and tied back to the WBS, system, and equipment tag. Forecast updates must explain the cause, impact, critical path effect, recovery owner, and required decision. Finally, approved scope, time, or cost changes create a new revision with a full audit trail. History is never overwritten. These rules clarify accountability across planning, commercial, quality, and commissioning teams. This slide presents a 2-week look ahead for procurement and engineering activities on the data center project. The schedule begins with the kickoff on August 1, 2022, then focuses on the early items needed to keep construction moving. Under procurement, bore piling, ready-mix concrete, reinforcement bar, and the adjacent site office are all targeted for August 2nd. Early works support follows on the same date, while the formwork, rebar, and concreting subcontractors are targeted for August 9th. The cutoff pile subcontractor is planned for August 11th. Precast hollow core slabs and long lead equipment are also identified, although no target dates are shown for those items. The engineering workstream starts with receipt of the IFC, or issued for construction drawings, targeted for August 2nd. Shop drawings are included as the next engineering activity, but their date is not specified here. The key assumption is that the underground PLN cable will be cleared by August 16th, allowing bore piling works to proceed safely. That clearance is the critical dependency behind the early construction sequence. This 2-week look-ahead focuses on construction, site facilities, and the early works needed to safely begin piling on the data center project. The most important constraint is the safety gate. Existing underground utilities must be located, protected, or relocated before piling can proceed. Construction activities include survey and setting out, site clearing and formation, and preparation and mobilization for bore piling, with a stated 14-day delivery period. In parallel, the team is establishing the site facilities, including the site office, washing bay, temporary water, and temporary electrical power. Temporary water is targeted for completion by August 14th, while temporary power has a 2-month completion period. The utilities work is shown as a critical early work stream. The dam pipeline wrapping is marked complete as of July 31st. Relocation of the PLN cable line is targeted for August 16th, and gas pipe relocation is also identified. Tower crane mobilization is planned 4 days after first piling commences, so utility clearance and piling readiness directly control that next step. This slide presents the integrated project organization for the data center project, with Nexera Engineering and Construction serving as the main contractor for both CSA and MEP scope. At the top are the project steering committee, project director, and project manager, establishing governance, accountability, and day-to-day project leadership. The organization then extends into several specialist functions. Head office support provides business, engineering, and MEP expertise, while the Data Center Advisory Group contributes technical advice, subject matter expertise, and consulting engineering. Commercial and project controls, general affairs and HR, procurement, planning, BM, document control, logistics, HSE, quality, and security provide the core management infrastructure. Delivery is organized across CSA and architecture, MEP delivery and commissioning, and testing and commissioning. These areas include discipline managers, package leads, site supervision, BAM and control specialists, commissioning engineers, and the associated document control roles. The titles and abbreviations shown here are organizational roles only, not personal assignments. Personal names are maintained in the separate staffing and responsibility register. Key abbreviations include PSC, PD, PM, CSA, MEP, and TCM. This slide summarizes the staffing plan for the data center project, with 26 people on board across construction, engineering, quality, safety, commercial support, and administration. The organization is split into 2 principal groups: 15 core project and site roles and 11 senior MEP, engineering, design, and coordination roles. Key positions include the project manager, CSA construction manager, 2 CS site managers, the HSE manager, safety officer, QA/QC leadership, surveyors, plant coordination, purchasing, and HR support. The technical team includes the senior MEP manager, electrical package manager, CSA engineering manager, planning engineer, BM coordinator and modelers, architect, and CSA drafters. At kickoff, 15 team members had already mobilized to site, while the remaining candidates were planned to arrive within 6 weeks. The MEP engineering manager was already mobilized as an expatriate role, while the commercial and engineering manager was still awaiting a permit. Overall, the staffing structure establishes coverage for delivery, controls, safety, coordination, and technical execution from the start. This slide presents the proposed site facilities arrangement for the first stage of early works on the data center project. The layout brings together the temporary infrastructure needed to make construction operational: site offices, the existing substation, piling subcontractor facilities, toilets, temporary electricity and water, washing bays, and designated laydown areas. It also identifies the 2 main entrances, security posts, and the areas associated with Tower Crane 1 and Tower Crane 2, together with their passenger hoists. The key point is that this is not just a location plan. It is a coordination and control tool. Access must remain available, Lifting zones must be properly managed, and temporary utilities must interface safely with ongoing work. The plan also flags an unusable access route that remains blocked, so that constraint needs to stay visible in planning and daily coordination. Weekly control should verify that every zone remains safe, available, and aligned with the 2-week look ahead. In this context, TC means tower crane, PH means passenger hoist, and S/C means subcontractor. This section focuses on developed site activities, with particular attention to utility discovery, protection, relocation, and evidence. These activities are closely connected, because understanding what is already present on a developed site is the starting point for making informed decisions about any work that follows. Utility discovery comes first. It means identifying existing utilities and understanding their location before activities affect the site. Protection then addresses how those utilities will be kept safe while work continues. Where an existing utility conflicts with the planned activity, relocation becomes the relevant consideration. The final point, evidence, is equally important. Documentation provides a record of what was found, what actions were taken, and how decisions were supported. Together, these 4 ideas create a practical framework for managing existing utilities on a developed site. As we move through this section, the focus is not only on the individual activities, but also on how they connect to support safer, better documented site work. This slide focuses on managing unforeseen underground utilities before construction activities begin, particularly bore piling on the data center project. The key message is that site readiness depends on knowing what is below ground, not simply what is visible at the surface. The layout identifies 3 existing utility interfaces: the dam water pipeline, the PLN electrical cable, and the gas pipeline. It also shows the construction gate, which is important because access and work sequencing need to account for these services. The control process is straightforward but critical. First, confirm each surveyed location and depth. Then protect the utility in place, or relocate it, before bore piling starts. No work should proceed without the required permit, method statement, and formal hold point. Finally, the team must record the actual condition and location in the as-built documentation, then close the interface risk. In short, this is a coordination issue involving the main contractor, CSA and MEP teams, and the utility stakeholders. Early verification prevents damage, disruption, and avoidable safety exposure. This slide presents the action plan and monitoring framework for dam pipe wrapping within the data center project. The focus is site readiness, with Nexra Engineering and Construction serving as the main contractor for CSA and MEP activities. The plan tracks each station through a sequence of activities: soil excavation, corrosion coating for ductile iron pipe, grinding and patching, pipe wrapping, and backfilling. For every activity, the table separates planned dates from actual dates, allowing the team to see where work matched the schedule and where execution moved earlier or later. The wrapping activity is monitored in more detail through the number of 1,000 mm joints and the corresponding wrapping quantity in square meters. The overall status is recorded as completed on July 31st, with a total quantity of 214.90 square meters. This is also designed as a live audit and reporting tool. Plan and actual dates remain editable by station, supporting weekly updates and making schedule changes traceable. Dam refers to the municipal water utility. This slide presents progress evidence for the dam utility protection work within the data center project. The specific activity shown is dam pipe wrapping, reported as completed by July 31st. The important point is that a completed physical activity is not automatically a released workfront. Acceptance depends on connecting the evidence to the closeout dossier: the treated station range, the completed quantity, the approved wrapping method, the inspection record, and the as-built utility reference. In other words, the photograph supports the claim of completion, but it must be tied to accountable documentation before the work can be formally accepted. The control implication is straightforward. Completion becomes release only after verification and evidence acceptance. This distinction helps prevent progress reporting from getting ahead of quality control or record control. For clarity, DAM refers to the municipal water utility, while PLN refers to the state electricity utility. Here, the focus is specifically on protecting and documenting the DAM interface. This slide presents the progress evidence for PLN cable relocation and utility access within the data center project. The focus is not simply on showing that excavation has taken place. It is on documenting the conditions and approvals needed before the piling zone can be released. The key evidence is the exposed cable interface and the actual workfront condition. From that record, the team needs to confirm the surveyed route, the required protection or relocation acceptance, safe excavation controls, the responsible authority, and the date when the piling area can be made available. The excavation itself must follow the approved permit, utility scan, and trial pit sequence, with clear exclusion controls in place. At the same time, the utility access point needs to be clearly identified and protected. It must also be incorporated into the logistics plan and the as-built utility control plan, so its location and status remain controlled throughout the work. Together, these requirements connect field evidence with safe execution, authority acceptance, and readiness for the next construction activity. This slide records a key mobilization milestone for the data center project. Site security is on board. The stated target was to commence by July 31st, providing the security function needed to support controlled site operations from the outset. The photo evidence should be interpreted through several practical controls. First, access must be managed, with visitor induction in place so everyone entering the site understands the required procedures. Second, the security setup needs to interface with both entrances and the temporary facilities. That coordination helps maintain a consistent approach across the active work areas. Security also has a role in managing traffic, deliveries, and the washing bay, where vehicle movements can affect both safety and site efficiency. Finally, daily reporting should capture security and safety observations, creating a record of what was seen and how the site was being managed. The evidence itself should remain date-stamped and traceable to the daily site record. That traceability is important because it connects the visual evidence to a specific day, a defined status, and an accountable project process. This slide establishes the photographic baseline for the data center project at kickoff. The purpose is not simply to show what the site looked like, but to create a reference point that supports objective progress tracking over time. The key principle is repeatability. Use the same viewpoints regularly so changes in access, work fronts, and logistics can be evidenced clearly. The first view focuses on site baseline and access. It records the initial boundary conditions, access arrangements, and adjacent interfaces, while also providing a reference for safe logistics and workfront change. The central workfront view captures the early works area. Observed activity should be connected to the released scope, measured quantities, temporary works, and any constraints affecting progress. Finally, the perimeter and logistics view looks beyond the immediate workface. It helps monitor vehicle and personnel routes, laydown areas, public interfaces, and emerging congestion risks. Together, these three perspectives create a consistent visual record that supports practical site control and credible progress evidence throughout the project. This slide shows how the weekly minutes of meeting, or MOM, remain consistent from week 01 through week 110, while the evidence behind them becomes more mature. The spine stays the same: baseline, evidence, variance, decision, action, verification, and accepted closure. Any unresolved identifier or decision carries forward into the next cycle, rather than being reset or lost. The control focus then evolves across 6 stages. Mobilization establishes the charter, WBS, authorities, site release, and register ownership. Design and information release confirm that near-term work fronts have current, accepted information. Procurement and FAT focus on design freeze, vendor evidence, logistics, and readiness before need dates. Construction tracks quantities, inspections, permits, NCRs, constraints, and workfront release. Later, the MOM must demonstrate safe energization and startup, then prove functional performance through CXL4 and CXL5 scenarios, including capacity, redundancy, interfaces, and recovery. Finally, transition and handover confirm that operations can accept, operate, maintain, and improve the facility, using complete O&M information, asset data, training, spares, warranties, risks, and lessons learned. This is a continuity system, not just a meeting record. This minute summary captures the decisions, commitments, and constraints that govern the next phase of the data center project. The team aligned that Phase 1, Day 1, covers the complete listed scope, with a 13-month works completion baseline to be established. Communication, acceptance, and approval protocols will also be formalized, and immediate IFC, or issued for construction, release is needed to unlock shop drawings. Early procurement is already moving for tower cranes, piling, concrete, and reinforcement. Temporary power, water, security, and site office packages have been initiated. 26 staff are on board, with 15 already mobilized to site, and dam wrapping was completed by July 31st. The most important constraints are utility clearances and mobilization. PLN cable relocation must be completed by August 16th, before piling can begin, while the gas pipe relocation plan remains open. Temporary power has a 2-month delivery horizon, and remaining staff and expatriate permit actions require active tracking. The project is authorized to proceed through controlled early works, subject to drawings, utility clearance, mobilization, and baseline governance. This action register translates the kickoff decisions into 12 accountable deliverables, with a clear target and status for each. The immediate priority is to establish control of the project, issue the baseline program for the 13-month works, submit the quality and HSE plans, and confirm communication, approval, escalation, and acceptance protocols. The design and mobilization work is already moving. IFC foundation and superstructure information is in progress, along with mobilization of early work subcontractors, site office and formation works, and temporary water and electrical services. The dam wrapping action is completed, with completion evidence retained. Several items require close attention. The PLN cable relocation, targeted for August 16th, is marked critical because it must support safe piling release. The gas pipe relocation plan remains open with a target still to be confirmed. Staffing and expatriate permit actions are also in progress, with a 6-week window. The register deliberately uses immediate, or TBC, where an original fixed date was not available. Those targets must be confirmed during week 1, so the team can convert this list into a fully controlled execution plan. This slide sets the agenda for the first weekly project meeting, with each topic tied to a specific decision. The goal is to leave the meeting with clear owners, dates, and escalation paths. First, we'll review weekly progress against plan, actual performance, cumulative results, and variance, using the project dashboard to confirm whether recovery action is needed. We'll then validate the baseline program, contract weight redistribution, total weighting, and S-curve logic. The next priorities concern underground utilities, including dam closeout, the PLN relocation plan for August 16th, and the gas pipe plan. Procurement must confirm delivery dates for piling, ready mix, reinforcement, formwork, hollow core slabs, and long lead equipment. We'll also check IFC information, shop drawings, and approval priorities, followed by site logistics for temporary services, offices, access, and tower cranes. HSE and quality submissions, permits, hold points, and survey evidence require either approval or firm closure dates. Finally, we'll review mobilization, vacancies, permits, risks, overdue actions, and blockers. The meeting should conclude by approving the recurring Week 1 report pack and its reporting format. The kickoff is complete, and the focus now shifts from alignment to execution. Week 1 must prove control, not just activity. That means measuring progress against the plan, closing constraints before they become blockers, updating risks as conditions change, confirming decisions with the right stakeholders, and protecting the approved baseline. In the next cycle, these practices become the rhythm of the project. The goal is straightforward: maintain visibility, resolve issues deliberately, and build reliable momentum through each weekly review.